In this video, you will find fundamentals of design intent, pros-cons of design intent, and of course, how to use it in daily life as designer. So without any further ado, let's get started. Before we jump right into design intent, we must understand the product development cycle. Product development cycle include numerous steps like concept, design, analysis, prototyping, testing all through to manufacturing. Now it's important to decide how much time we should spend on design. Because through all these steps, the most fragile step is design phase. Great design will lead you towards the great results, but sometimes designers need so much time to change the design, it is non-profitable activity to any organization, or individual. Almost 33 of designers have felt the situation, when they had to do last-minute design changes, as their clients desire that, and, at that time, frustration goes on their mind. If even small design changes take lot more time, clients and consumers will give values to you, when you, or your organization give them physical, or virtual product as same, they don't count your efforts, and, bitter truth is that, it doesn't even matter, that how hard you try to change, or make your designs, only your results are matter, at any stage, from your client's site. Intent means that what we intended, when we change our design. So that our design gets changed as we expect. Basically, design intent means, give some sort of intelligence to our model, so it can change automatically as we expect. Now let's see how design intent can implement on different stages. There are mainly 3 stages to maintain the design intent in your models: sketches, part, assemblies. In the sketches you can give information to your model, in form of different dimension schemes or datum features like points, planes or axis. Same on the part level design intent and also, on the assembly level design intent. In part modeling most important criteria are feature selection and method of use of features, as well as in assembly environment, whole assembly can be controlled by some equations and relations, and also, top-down design approach will give you tremendous control on your design. Later we will see these advanced topics in details. I'll try to post another video for complete demonstration for all the various aspects of design intent, so you can understand it in better way. Now, how to decide what kind of strategies we have to use for our model. Simply ask these questions to yourself: what are the requirements of model, what is the feature, function do I need to model so it can become so flexible for future changes, what are future changes may be need to implement in this design, for those future changes, is my modeling strategy is robust or not. Now let's jump to the common myths spread across the designers and students. First one is about feature trees. Some designers and university students still believe that feature tree should short as much as possible, but it's wrong. And what are the advantages of shorter feature tree? If your model can't update as you expect, even though it can be a good practice to use less number of feature, when possible, for less cluttered model tree. Second one is speed. Some designers or students think that why should I waste so much time to model, if I can do it in couple of minutes, but it's not the case every time. Sometimes even simple models can't update and adapt small design changes and leads you to regeneration failure. And the last one is about difference between looks features. This is very important to understand for early learner students who have no to little experience in design. For X, if you put simple hole in 100 by 100 by 35 mm plate with sketch command, and after that, you realize that it should be counter bore, so you cannot change it very easily. If you only concentrate on look of the model, you can put yourself in troubles. That's all about for this episode of Design Intent. See you in the next one. That's me signing off. Thank you.